simplified projectile motion, really simplified to an extent that is a bit annoying to me because I'm used to breaking it down, into vertical and horizontal, calculating the time it takes to fly up to here, and then calculate the time it takes to fly downwards. It's quite fun for me. But with this equation, it becomes straightforward. The question is, will they supply this equation in the exam sheet, in the physics exam sheet? So we don't know. Since we don't know, it's good for us to know how to analyze projectile motion, just besides using this cheat sheet, So you can use the Suvat equations. Remember, we said we use the Suvat equations. So we can use the Suvat equations. For example, we could say, we have the hypotenuse being the velocity 30. So the velocity, the vertical aspect of the velocity. And remember that the 30 is u, initial velocity. So the u in y, the vertical component will be equal to u sine 60.
Theta.
In this case, yes, theta, which is 60. And the horizontal one, u sub x, will be u sine theta, because we're using the letters. Anyway, yeah, u theta. Yeah, because we haven't substituted. So immediately, that will give you a value. So here, u sine theta, what does it give us? So u is 30, sine 60, gives us 25.9. So approximately 26. 25.9 meters.
It gave me...
And what about with the cosine for the horizontal?
Wait, it's cos. It get 15.
Good, it gives 15. Interesting. The initial velocity, you have a higher vertical aspect than a horizontal aspect. Isn't that interesting?
Yes.
Now, that's why the projectile accelerates up. This is the initial, just the initial. Now, one thing that we have to know, something very special. Throughout the journey, when you look at it horizontally, what happens to the velocity horizontally? Does it change?
No, it does not.
It doesn't change. So ux is the same through the journey. So it says if you had a camera following the projectile, the camera will be traveling at the same rate just as the projectile. Looking at the horizontal aspect, you just see it, a straight line moving like this, right?
Yeah.
That's amazing. That's just the horizontal aspect, or the horizontal component of the projectile is constant. So it's 15 from the beginning. In this case, you say ux is 15, but also you could say vx is 15. It's very important because we're talking about initial velocity. This is the start of the journey. So we have the arrows. This is the start of the journey. Why you calculate this? Because now you can use other Suvat equations. Let's say you break this down into two. You say, look, I need to know, first I need to know how high it goes, because in the end, what I want is the horizontal displacement. But how do I get the horizontal displacement? Well, I might remember that velocity is equal to distance over time. However, what I'm looking for now is displacement. So displacement will therefore be VT, right?
I'll mute myself there's something printing. I'll mute myself, but I'll keep listening.
No problem. So we will have D is equal to VT. However, you soon find out you don't have time. So let's look for time. So we look at our Suvat equations. We think, okay, let's talk about V is equal to U plus GT, since we're flying now, GT. And then we think, okay, we don't have V. We have V. Now we're looking at the part when the ball goes like this. So this is the part when it goes up. So going up. So as the projectile goes up, what info do we have? We have that V and Vy will be 0. At this moment, it will go up and then it will stop. So its vertical component, Vy, because the final velocity at this part of the journey, which is basically half of R. So this is R over 2, half of the journey. Vy will be 0. However, uy we have calculated to be 25.9. uy is 25.9. So we have data. So we have vy, uy, and then we have g. G is 10. And since it's going up, we can say g is minus 10, just for coherence. Minus 10 meters per second squared. And then what else do we have? We want time. So time is an unknown. Time is unknown. Now, can the first equation help us? It seems so. Seems like it can help us. So therefore, here we know that Vy is equal to Uy plus Gt. Now, we've just said that Vy is 0. Therefore, we'll have that Uy, the initial velocity, will be equal to minus Gt as we put the Gt on the other side of the equation. And when we plug in the data, minus 10 times time. Okay, so Uy is what? Uy is 25.9. 25.9. And then that will give us T, whereby T, again, I don't use equal, I just put an arrow to indicate that this is where I came to, whereby T will be equal to 25.9 all over 10, because minus times minus is just positive. So my time, which is correctly so, not negative, will be 25.9 divided by 10, which is just 2.59. So approximately 2.6 seconds. 2.59 is approximately 2.6 seconds. So this is the first half of the journey. Now we could think, we have time, right? So if the first half of the journey takes us 2.5 seconds, we remember that even though we calculated this using the vertical aspect, we could use the horizontal aspect. So let's say going forward. Going forward. So we have time now. Why are we using this time? Because we know that the velocity is the same. So if it takes the same time to move to this half the journey, we can use the same velocity. So we can say, look, again, the distance will be equal to v, in this case, ux, the initial velocity, times the known time. So what is the initial velocity? We know the initial velocity is 15. Now we're talking about the x component. What is the time? We just calculated that the time it takes to do half the journey is 2.56. So 15 times 2.56, 15 times 2.559, not 56, because I said it's close to. What happened here? It's 2.59, not 2.56. So let me just correct that. I'm carrying an error. It's 2.59, not 56. 2.59, which is basically 2.6. So reasoning, we see 2.59, 2.59. So we multiply that by 2.59. It gives us 38.85. Now, this is the first half of the journey in the horizontal aspect. But we know that V is constant throughout the journey. V, we know that U sub X equals constant throughout the journey. Throughout the journey. Therefore, we can also say this will be the first part of the journey, distance 1, but we can also say then distance 2 will also depend on the very same velocity, 15 times time. Now, how are we sure? Are we sure that the time taken in the second part of the journey is the same? Well, if you want to be sure, we can calculate it. Basically, it is the same. But if you want to be sure, we are allowed to calculate it. Let's calculate it. So let's find T2. So let me just point it here. Let's find T2. So now we know that the part of the journey we're looking at, the ball is coming down. The projectile is coming down. And When it comes to the vertical aspect of it, uy becomes 0 because it starts at 0 going down, of course, following this path. So uy is 0. The vertical aspect is 0 here at this point. However, ux exists. Ux is not 0, it's 15. But we want time. So we want the vertical aspect. So it starts with a 0. And what about uy, vy, the last velocity? We don't know. The last velocity we can't assume. We don't know. But we know g. We know g, which is 10. And we want time. So this was very hectic. Oh, okay. So now what could help us is something very strange. How about if we knew the distance is falling? Well, we can know that because we know the distance it went up. It's the same distance. So it went up by how high did it go up? So let's find that out. So we have you have v squared sutat plus 2gh. So we could analyze the height by saying, okay, v is 0. We don't. So we can start at the beginning. We can find out that out looking at when it was going up. So we're looking at these the y components, as if we've gone back to the beginning. So from the y components in the beginning, going up, just a minute. How can we find it? Going up, we could calculate h because we know that the v is 0 when it goes up. So u squared y will be equal to 2gh, whereby we can find the square root of that. In fact, this has to be minus. This has to be minus. So u is got a value. U has got a value. So I'm just surprised. I'm just a little bit afraid because there's a minus sign. Okay, there's not a problem to be a minus sign because the g is negative. It's going up. So uy will be the square root of minus 2. Inside there's a minus 10, which is the g, and there's a height. So no, this is not how we solve it. Sorry, we want height. So no square root for now. We want the height itself. So what we do, we will say the height will be the u squared over 2g. So what we do, u squared, we know, we're talking about uy. So it's 25.9 squared, 25.9 all squared, and divide all of that by twice the negative gravity. So that gives us what? So we're looking for the height. It will help us to find the time. So it's 25.9 squared divided by 20. In fact, we can say minus 20. It's a negative. So we get that the height this ball went up is minus 33.5. Minus because it's working against gravity. It's going up 33.5 meters. Anyway, now why does this number help us? Because remember, we declared here that, we declared here that D2 will depend on 15 times time 2. But time 2 required us to calculate the height, so we could apply it in another equation. So I'm looking for that equation, for such equation. It might be hidden here. So let me just go up a bit. I'm looking for space now. Oh, so we still have ample space. Okay, so because we want to apply this here equation, so we need time, but for time we can find the distance going up. So what equation can we use? Now we have the distance going up. We have the distance, the ball comes down. So let's just calculate, use another equation to find the time. So I can't think of another one besides h is equal to ut plus half gt squared. Can't think of another one. So let's go back and look at the journey down. It starts at uy is 0. So this whole component, which is a UI, we're looking at it vertically, becomes 0. And then we have h, which we know now. H is equal to half gt. So 1 times square. So what we do, we multiply by 2 both sides, so that somehow we have the square root of h, square root of 2h over g. That will give us the answer that we need. Now, since it's coming down, g is positive. So we're looking for time now. So it's the square root of all of this, including the g. So we're looking for the square root of 2 times 33.5, 2 times 33.5, all over 10. Positive because we're coming down. So the square root of all of that will be square root of 2 times 33.5 divided by 10. But my square root should cover everyone. So let me just delete this and find this. So it gives me 6.7. So square root of this answer gives me, so my time here again is 2 check this out, 588 seconds. So in the end, we proved that the time is the same. It's good that we know now, we are sure, because now we can find the distance too. Distance 2 of the ball going down will be 15 multiplied by 2.588 seconds. So times 15, times 15, that gives us
38.
Indeed,
38
gives us another 38 point what? 0.8, right?
Yeah.
But this is D2. So how do we find the complete R?
We add them up.
We add them up. So we can just say 2 times 38, or just, okay, D1 plus D2. So we will come up with 38 times 8 plus 38, 0.8 not times 8. So that is like twice. So what do you get? What's the answer?
77.6.
Basically 78 meters. So